Hey everyone, welcome to the Dapr 1.18 celebration event.
Yeah, it's super exciting to be here with you, Mark, and everyone else and the crew. It's only been a few months in our last celebration event, but here we are again with another great release of Dapr. It's fantastic.
Yeah. Last time it was like February, I think, right? And then it was about like workflow versioning and what else do we have here, Mark?
We did, yeah. I mean, actually, it wasn't that long ago. Back in February, we did a 1.17 release. Inside that, we focused a lot on management, CLI commands for workflow. We did a lot about versioning. I think that was the big feature that came out then. Yeah, of course, definitely. Now we've got a lot more that's happening inside here. Let's get going then. Let's dive in and talk about what the highlights are in this release. I want to give too much away, but I would say that the thing that really stands out in the 1.17 in this 1.18 release is all about bringing kind of additional security into workflow, and particularly that's all about how this work we've done in terms of workflow propagation, in terms of tracking the previous workflow events, and importantly, taking advantage of that in order to do tamper detection. It's a pretty cool feature, something we're going to dive into a lot.
Definitely, yeah. But next to workflow, there are a lot of other things which we have. Some of we are highlighted here, like hot reloading for all resources is now stable, right? So all of your PubSub subscriptions, all of your HTTP endpoints, everything is now hot reloadable. So that's actually a great feature. Next to that, the jobs API is now also graduated to stable, which is also a very important fact. And there are like lots and lots of updates to the Dapr SDKs as well, right? So of course we couldn't fit it all in one slide. Definitely check out the Dapr 1.18 release highlights to see everything about that.
Yeah. All right.
Yeah, so the agenda, right? So first up will be Jeroen talking about verifiable execution. That's a term we will hear about a lot today. Then we have like Dapr end user, Ursine, talking about how they're using Dapr Workflow at Uniphar. It's great to see that. Then we'll have Josh doing 2 sessions and also Bilgin doing 2 sessions. And then we have Casper talking about Dapr Agents. And last but not least, we will refer one Lego kit, which we typically do. And for this edition, I have the Back to the Future set because, well, we're talking about like workflow history propagation and history tampering. So yeah, I thought this is a very good fit, What if Back to the Future was actually using Dapr Workflow? Well, yeah, they would have been able to change any history, right?
So you haven't got the messy Lego kit then?
No.
I was in a store yesterday. I saw the messy Lego kit, and it was $200, and I was like, "Wow!"
No, that's insane.
It could be the other theme then.
No, exactly. Yeah, but yeah, please stick around until the end because at the end of this event, we will raffle away one of these kits. So please stay tuned.
All right. So with that, let's dive in and let's hear from Jeroen. All about verifiable execution. Take it away, Jeroen. You're on mute, Jeroen, sir.
Yes, I will. I just want to point out to Ravi in chat who gave a link about the Dapr 1.17 celebration event. What is that?
Oh, what it is?
I mean, I just want to make sure we didn't put a 1.17 celebration out there instead of one.
Oh, yes. This was just a bit of a recap. Yeah. If you want to go back and if you need more celebrations,
Okay, looks like we confused a few folks then.
Yes.
All right. Great stuff. Well, hey everyone. My name is Jeroen Schneider. I'm a maintainer of Dapr and one of the co-creators of the project. And today we're going to be talking about verifiable execution, which is a feature we added in Dapr 1.18. You might have heard the term durable execution, which is really just a very fancy way of saying if a process crashes, it reads back its state and continues on. There isn't one accepted way of doing that, but Dapr has this feature that allows you to essentially recover any type of agentic workflow or app from failures, whether it's a complete cluster shutdown, a bug in your code, or something else. And this is great for reliability. But another piece of it, of just execution in general, is being able to verify exactly what you did. Now, why is this important? Why should you really care about it? Well, let me ask you a question. Let's say you have an agent that talks to some third-party API that then talks back to your agent, and that agent approves a transaction, and it talks to Stripe, and then it verifies the merchant and it writes the data to a database. How can you actually today prove exactly what happened? Well, you're going to say, well, I log everything. I log this request to this API. I log the request to the database. I have tracing. I have open telemetry. Well, that's not really going to work. All of those things are essentially plain text. They can be tampered with. They can be audited, or they can't be trusted in an audit because they can be mutated. And if they can be changed, they cannot be trusted. Logs and telemetry are great. They've been there for a while, but they're not actual definite proof about who did what and what data was inside of a transaction as it occurred. If you're withstanding a security audit, a regulator concern, if you're doing a root cause analysis for some sort of attack, you have to be able to audit your entire system and be able to answer the question of, can we actually prove that our systems were not compromised along the way? Were these actually our systems that did what they said they did? And you need to do it in a cryptographically attestable way, meaning in a way that is tamper evident. And this is exactly what we're doing inside of Dapr 1.18. Josh is going to deep dive into that later, and he's actually going to show a great demo about how this is happening in real time and about how Dapr can detect in real time the data has been tampered with, which is amazing. But this really is, I think, a combination of durability and security together. It's really the first time where you can write your workflows the same way you would with all of your durability guarantees, but now you can actually get something that really will make your CISOs happy and security teams happy, because if you'll ever be asked, hey, how do we know that this system wasn't compromised after a potential breach? Or how do you stand up against a regulator to prove what you did? Well, you don't really have to do anything. You essentially need to enable a simple field to go from false to true in Dapr, and we automatically sign all of your workflow history. And this is incredibly important. As we deploy more agents into production, the ability to prove who did what only becomes more important, because these are not just machines anymore. These are machines acting on behalf of other machines, acting on behalf of humans, and the inception can go, way, 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 way back, or into the future. So with no further ado, let's move on to our next item.
All right, that's just fantastic background there, and thanks, Jeroen. We're very excited about getting that incredible feature in this release. With that, Oshin, would love you to give us your thoughts and intro about how you use Workflow today.
Hi, how are you guys? My name is Oshin Haken, and I work currently with Uniphar. So I should probably introduce Uniphar a little bit. I'm told it's pretty much the biggest pharma distributor in Ireland, but it has a global presence. And it started in 1967, grew, and now it's in 160 plus countries and 200 plus partners. And all of it is about getting, the critical drugs and supplies to people in need in hospitals and places like that. Obviously, this is now all IT driven, and when you grow sort of two ways: organically and acquisitions. And acquisitions can be obviously somewhat of a challenge, because you inherit the infrastructure and a culture and a tech stack from the company, and just maybe completely different from what you've been using so far. And traditionally things would have been on-prem and etc. So Uniphar realized, and our CTO actually put it in no uncertain terms, if we ever had some high-level security incident and our infrastructure was compromised and our warehouses stopped shipping things, people might actually die. So that's the kind of criticality here. And so the whole new initiative was launched to do a major overhaul and modernize infrastructure. And obviously security is absolutely the first concern. Things are now moving into cloud, so you have much less of concerns yourself. You have your partner, your cloud provider that deals with all these little nitty-gritty things on your behalf and kind of enforces certain operational standards. And now we're also getting a lot of AI interest, and overall we're just trying to come up with new products, new initiatives, so that we, Uniphar can continue to grow and serve its business partners and clients just that much better. And that's this slide. So if you can move to the next slide, please. And my name is Oshin Haken, as I mentioned, and I kind of work now on the platform and DevOps and apps team. And we really, when we started this whole initiative and the team, we did our homework and we looked at many frameworks, and eventually we chose Dapr, and we did it. Obviously, the Microsoft kind of background all helped. We liked what we saw. We liked the features and the alignment just simply there with the Diagrid or Dapr mindset and our. And I actually would like to thank Diagrid to have this opportunity to speak here, because two ways. We're proud of what we do, so we obviously like to share that, but also it just made our life that much easier, and we see that kind of dedication, and so it makes our life easier. So thank you guys. And when I was asked, would you be willing to present, I had no hesitation. And so when we chose Dapr, then we started to use it, and I was kind of leading that and came up with some initial applications, and have since been evangelizing the use of Dapr, and the number of applications very much increased. And we use, all the Dapr features, mostly kind of actors and workflows. There's my email in case you ever want to kind of ask questions or follow up. So please don't hesitate. Next slide, please. Yeah. So I kind of picked two kind of applications that represent a good sample of what we do. The first one, codename Mammon, it's a cost management solution. So just to give you a brief idea here, we're Azure House. As you develop new applications, new streams, new initiatives, you provision a number of resources, and obviously there's cost. And so at some stage, you want accounting people to understand where that cost can be attributed to. They don't understand technology. They don't understand cloud. We do, but we're not accountants. So we meet in the middle. We give a report which uses this sort of accounting concepts of cost centers, but we crunch all the numbers, scan all in Azure landscape, crunch the numbers, give them the report, and they can take it and then do their budgeting work. So in terms of technology here, when I started to look into it, I realized, well, your Azure landscape, that's complex. And the number of resources may be very high, and the type of resources is huge. And the solutions that were available to us through Azure did not meet really our standards. We wanted to do a little bit more. We wanted to look not at just resource or subscription or resource group level. We wanted to also split the cost of certain resources because they're shared. A good example might be Cosmos or AKS. We have custom logic to be able to look at the Cosmos, look at the usage, or look at the pods in a cluster, look at the metrics, which ones are heavier, which are lighter, and we have the logic then to split the cost of the cluster or the Cosmos or some other resource types, be that VDI, to these cost centers based on usage, based on number of session, number of DTUs. So there's that custom logic. And I wanted to write a code that's easy to maintain, easy to support with real good observability. So it occurred to me that as I'm looking at these resources and all these levels within Azure, they actually fit workflows. So the process that's been implemented now is a hierarchy of workflows. We have a tenant workflow, which starts subscription workflows, which can start resource group workflows, and these specialized workflows for these special resources with their special logic. And so it ultimately fans out and eventually fans in. And at the end of when all these workflows are orchestrated and completed, and we get that from Dapr. At the end of our tenant, the top level workflow, we simply send a report. So this just made the code that much easier, lighter, because most of the code now, if you look at the repo, and by the way, it's open source, and most of the code is really about the business logic. There's virtually very little code that deals with these kind of nitty-gritty orchestration concerns. And by the way, we gave kind of more detailed talk on this in KubeCon Europe 2026, and it's available in YouTube. So if you're interested, I suggest you go there. So this is Mammon, and it's been working great, and accounting people are happy, and we're happy, and we've extended it for a few times now, and it just made that much easier. The other solution I picked, we codename it Flux, And this is our first kind of agentic real solution. We, in DevOps team, we often get requests from business stakeholders to provision new resources, provision new teams, provision new licenses, onboard, ADO, GitHub, etc. So we thought, you know what? Why don't we give them an agent where they can interact with it and do what they need to do without us having to do it for them on them created ticketing, etc. So, but obviously this is a complex logic. When you look at modern AI, oftentimes it's read-only, data sources connected, numbers crunched, some output, some decision on that. Now, this is a solution that will create and delete resources, critical resources in our infrastructure. So we really wanted to make sure that it's fully supportable, safe, testable, etc. So we came up with the design. Obviously, the initial approach could have been we simply write a bunch of MCP tooling and instructions and just hook it up all together and let it run. What would the agent do? We wouldn't have that kind of a control. So we thought maybe the better approach here is to have specialized agents. One deals with the routing, which ultimately to us means you get a human prompt, you analyze it, you validate it, you identify what it actually means. Then you can derive pre-cooked, templated, curated prompts to specialized agents for Teams, for ADO, for GitHub, for Azure, etc. So these specialized agents, then they can see these curated prompts, and it just that removes that uncertainty to a large degree and promotes predictability of what the input is and therefore what the output is. And we realized, okay, this coordination between the agents, well, we have Dapr. So this solution really at the core is a Dapr workflow which orchestrates agentic coordination. And it's great. And now we had great observability about the workflow itself, but also a lot of telemetry from agents, cost, etc. So we're very happy with that design, and this solution is being developed as we speak. And but this structure seems exactly fit the need.
That's fantastic, Oisin. We're going to have to move you along a little bit faster here because we've got a lot to cover today.
Yeah.
So let's just please zip through this a little bit here.
Yeah, so look, as a developers, we get all these built-in features, and so we don't have to deal with it ourselves. So we like that. As DevOps, I get this unified observability, be that agentic or non-agentic application. So I like that. We really love Catalyst now. And business, they get higher success rate and reduced cost. So everybody's happy. Thank you very much.
Well, fantastic to hear your story. We'd love to get you back again if you want to hear more about this on a community call that we can do in the future. But really appreciate you turning up today and talking about your workflow solution, your agentic solution, how Dapr and Workflow has really helped you solve really hard business problems. And it's fantastic to hear. Thank you.
Anytime.
So Mark, what next?
Yes, I want to do like a little poll because we're talking a lot about workflow and later on also about like agentic AI, but I'm very curious what kind of workflow solutions people are using. So what kind of workflow engines are using. So let's do a quick poll. Let's start it right now. So people should see it in the right-hand side on their in their screen. So have you used a workflow engine before? And if so, which one is it? I mean, yeah, we would be very happy if it's of course Dapr Workflow, but be honest. And yeah, there's also like maybe you've built an in-house solution, right? That's often what I see as well. That's usually a bit of a scary one if it's like an in-house built workflow solution. But yeah, I'm very curious what people are using. Also, no, right. Of course, also a valid answer. Yeah,
you put BizTalk on there.
Yes, yeah. So BizTalk was actually my first introduction to workflow solutions. That was a long time ago, but I think it's still running, right? It's still like actively maintained. I think BizTalk.
I think so.
Yeah. No, it was not a super pleasant experience, to be honest, to be working with that. But yeah. Okay, so we get like quite a bit of variation indeed. Yeah, a lot of Dapr Workflow, which of course is expected, but also some other stuff. Yeah, if you're using one of the others, yeah, please feel free to use the chat to talk about. Okay, how can this be improved, or what you like about it, what you don't like about it, and we can talk about it asynchronously.
Yeah, there's actually a repo somewhere that is just called, I think, best workflow engines. I think they list about 70 of them in total.
Oh yeah, there's the awesome durable execution on GitHub. So there are these awesome lists, yeah, and those like contain so many alternatives that is, yeah, it's quite interesting to just browse through it indeed. Yeah. All right, let's continue. Yeah, let's talk about Catalyst a bit, right? Because yeah, Catalyst is like the best place to run Dapr Workflow in production, right?
Well, yeah, I mean, we've worked hard to make sure that Dapr 1.18 is integrated into Catalyst. You can sign up for Catalyst totally free. It's a hosted solution for visualizing workflows, managing workflows, building projects around these all. It's a great place to take your Dapr projects, deploy them into Catalyst, run them, try them all out, have a hosted endpoint around these things. We keep up with the latest releases inside there all the time. And it has an amazing workflow visualization and agentic application inside there. We'll be seeing it today. So sign up for a free account.
All right. Yeah, I'm definitely going to see a lot of demos today of this. So this will be good. All right. So next speaker is Josh, and talking about verifiable execution. Hello, Josh. All right. I will stop sharing the screen so you can take it over.
Yeah, sure. Sounds good.
All right.
Cool. Good stuff. Can you see my screen?
Yeah. Yes. Yeah, you're good to go.
Good stuff. Cool. Yeah, so hi everyone, I'm Josh, a software engineer here at Diagrid and a maintainer of the Dapr project. And yeah, today I'm going to talk about the new feature of the history signing with tamper detection, and also the history context propagation. And they're a bit of a mouthful, so we'll walk through them together. So the problem first, I think Jeroen summarized it really well at the beginning of this webinar, but I wanted to give maybe like a real world example of why this feature matters, and yeah, the kind of things it prevents. So back in 2025, there's a company called Bybit, which had a big hack, I suppose you'd call it, a big attack, whereby attackers were able to modify the target address of a payment in order to move money to the account effectively. And this led to a huge amount of money lost. That's a big number on the screen, 1.5 billion. And the problem here was that I believe the UI of the company was showing the correct address, but on the back end, it was tampered with. And because there was no verification of the stored values, it was able to go undetected by the humans, and then the money was lost. So that's the kind of problem class that we're trying to solve here. So how do we solve that Dapr workflow? So Dapr workflows, by definition, are its history. So behind the scenes, as you kind of you're writing your code in your code first workflows, with your workflows, your activities, and you're calling workflows and call activities, blah blah blah. Behind the scenes, that gets put into a history log that gets saved into your workflow, or behind the scenes an actor state store, and these are saved as a sequential series of events that happen. And they get stored in these kind of chunks, these linear events that happen one after the other. Now the issue can be that, for example, with the hack that we were just talking about, what happens if an attacker was able to go into that state store, let's say, and flip a bit? Let's say you change the amount from 500,000 to $1 million, or to 0, or you change the target address, something like this. How are you able to detect that and prevent that from happening? So that's what we are solving for 1.18. So the way that we're doing that is through, again, what we call history signing. So in Dapr, as you might know, the kind of atomic value of an application is this concept of an app ID, which is an application identity, which once it joins the Dapr cluster, it talks to Sentry and receives a spiffy SVID, so spiffy verifiable identity document, and that is an X509 certificate that contains the identity of that application, signed through the root bundle, the root trust of the cluster. And that certificate is what we use in other parts of the system for MTLS and things like this. And yeah, again, contains the identity of that application. Well, but since it's a certificate, other things you can do with certificates of signing. So what we've done is, again, if you enable this option, as a application is working over a workflow or activity, what have you, as those history events assigned to the state store, it also attaches signatures and a certificate to that history log as well, which means that at point of time, this particular identity did this work at this time with this certificate signed through Sentry, which means that if you unravel it towards the end, or again through propagation, which we'll show in a second, it means that you can prove, you can cryptograph, audit the history that a particular application had for that workflow at a particular time. And indeed, this is true, and I guess we'll talk about this webinar with multi-app flows, where you kind of pass the workflows across and you call each other applications. They all will have different, they will all have chain of custody of the workflow during their kind of time of execution. And so what you get is this cryptographically auditable, again, kind of history log. And what that means is when you replay the workflow history, you are able to verify that that particular application actually worked on that data using its identities. So yeah, that's how we're implementing that. And if you've got more questions at the end, maybe you can have time to talk about that, or you can message me how that's working. Now that we have that history signed, it also means that we can do other things like history context, it should be say context propagation. And what that means is that as you may be familiar with a workflow, for example, where you call a child workflow on another application, and you can give it an input. You can give it an input, but similarly, you can also give it the history of what's happened as well. And why that is interesting is because previously, if you tried to give the history of what's happened, you could just lie, right? You could just say, oh yeah, my parent workflow, the approving workflow, the kind of fraud detection workflow, yeah, it like return true, we're all good, go ahead and like, pay me $1 billion. You can't do that now, because when you send the history, you're also going to be sending the signatures of it, which means that the payment application at the very end will be able to cryptographically prove that the fraud detection application did actually have chain of custody of that workflow and actually did execute and said yes. So at any point in the chain, you can prove what's happened before, so you can't break the chain. Yeah, so that's pretty powerful. Yeah, cool. I hope that's all making sense. And then because we have that history, we can then, as I say, do interesting things with it. So for example, it might be interesting to do, I think we were discussing before about like routing decisions based on the history. In my particular demo I'll show in a bit, we're going to do authorization decisions. And we can, because it's code first workflows, it means we can kind of exec out kind of any framework we want. So in my example, I'm using a Rego, for example. So I can use the history of the Dapr workflow as an input to Rego policy to make decisions about approving a payment based on the input to some kind of previous approval or something like this. And we'll walk through that in a second. Yeah. Cool. Yeah, so let's go on to the demo. So I've got two applications, and I'll be showing in a second. So I've got an orders application, which is Go, and a payments application, which is Python. And the idea is that the orders application will create the order. That will then be approved by human or whatever else, maybe another system. And then once it's been approved, it will then call the payments application, which will then do authorization of that payment based on who approved it, right? Is the idea here. So first I'll show you the happy path, so what it will look like, what it should look like normally, what would happen when it's not allowed. So again, it will go through the history and decide that it's not allowed, and then we'll do a demo where we tamper with the history. So we will go into the state store and we'll edit the dollar amount to be a different value, and because that will break the signature, the hashes won't match. Then it will fail the workflow and it will fail closed, and the payment shouldn't go through with any luck, hopefully, if the demo gods are with me. So hopefully you can still see my screen. So I'm just going to show you a bit of code here very quickly because there's a couple bits that I wanted to show. So this is the Go application I've got here. The thing that is interesting to show here is we're going to wait for the external event, which will be the approval, which will simulate an approval from a particular authorizer or what have you. And then we're going to call the settle payment child workflow. That's going to be called on the payments app, so a different application. And we're also, this is the new piece being added with history propagation, where we're going to propagate own history, which means we're going to propagate the history of this workflow. And then on the Python application, this is the interesting bit where we settle the payment. What we have now added is being able to get the context get propagated history. So we have the history here, we can get the workflows, we get the workflow, we get the activity, the approver, and that's what we're going to authorize. And then we're going to call another activity, and that is, if I find the right one, it's going to call out into OPA, into a Rego policy, which I've got over here. So very quickly, I struggle with Rego too, so I'll go through quickly. But essentially, what this Rego is doing is it's inputting this kind of data JSON blob here, and in here I'm going to say I approve Alice and Bob, and these are the limits for Alice and Bob, and that's effectively what that is doing. Is this Rego is just passing in that data and then returning true or false based on whether the inputs allowed, right? Cool. So that's enough of that, I think, and we'll start off with the approver demo. So I've just put them into a script, so it's quicker to run and simple, and hopefully make less mistakes. So what's happening now is I'm spinning up those two applications and I'm running them against Catalyst. And let's have a look here. Yeah, so if I go into Catalyst, you can see that I've got my two applications running here, which is good. And if I go to my workflows, that's right, we should have one running. And so you can see here, the account is for $5,000 from a merchant Acme, and it's waiting for an approval. So let's raise this event, and let's raise it with Alice. I'll pop that in there, raise event, and with any luck, fresh. And so what's happened is it recorded, got sent over to the payments application, did the authorization. You can see here that the request and it was approved, and then we did the paid out. Cool. So that's good. Let me close this. Let's see what happens when we put a bad value in. So let's run this again. And this time we're going to put Mallory in. So let's get next workflow. Just run here. And we're going to approve it. Paste it in. And again, this is, I've put Mallory in the history of the workflow itself. That gets over to the Python application. That extracts Mallory from the history, and then that goes through the Rego policy, and that gets denied. So it goes to this authorized workflow or activity, I should say, and it says, yeah, reason false, and we don't get our payment. Cool. Good. So that is the approval demo, and I also want to show tampering as well. It's one tool. So let's hope. Good. So what this is doing is, again, this is spinning up those two applications, and we're going to create a file again. And then what we're going to do is we're going to simulate an attack. And so what we'll do is we're going to edit the values in the state store to 9,000. So you see here, previously it was 5,000, and now it's going to be 9,000, which is obviously the wrong amount. And again, because of the chain, that means, and everything signed, including a hash of the previous event, because you've broken that chain, that's then going to, the verification and the runtime is no longer going to be valid, it'll break. So let's pull up that workflow here. So I've got it in a running state, and good. So we're going to do the same as before. We're going to approve as Alice, which in theory should work, right? Because Alice is a an approved person and I re-go, we raise event. Oh. Am I still online? Am I still here? Yeah.
Yes, you are.
Oh, something's not very good. I wonder if it's already broken. What have I done? Let's have a go again. Let's try one more time. Something is not very happy. I wonder if I've broken something with the state store potentially. Let's try it one more time very quickly. Although we're running out of time, aren't we? So I'm gonna give it back, I think, and I'll try and get this working in the background. Say again, sorry.
Yeah, if that doesn't work, if you can show like a previous run, I think that would.
Oh yeah, of course. I've got lots. So you can go to tamper 1. This is one I did previously, for example. And yes, here we are. So it says workflow history signature verification failed. The tamper signature 0 events, blah, 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 blah. And that's telling us that the value was modified in the state store and the certificate's no longer matched. So yeah, cool. I'll go back to the presentation.
So effectively,
yeah, I just got one more slide.
Yeah, that case study you had right at the beginning about the 1.5 billion would have been prevented.
Correct, exactly. Yeah. Good. So I've got some links here. If you want to go check out these new features and how they work and things like this. And yeah, feel free to message me on Discord or something like this if you've got any questions.
All right.
Cool.
Yeah.
Thank you, Josh.
Thanks, Josh. Yeah, I don't think there are any questions now, but like I mentioned, feel free to drop questions in the Dapr Discord as well if you have questions for Josh about this. Yeah, and yeah, it's funny that you say that the demo was a bit like temperamental. So is it temperament with an A or with an E? Was it like an intentional wordplay on temperament? I don't know. I thought it was quite funny. Yeah. Thanks for doing that. All right, let's move on with our next speaker, and that is Bilgin, and he is going to talk about workflow access policies.
Yeah, thanks, Mark.
So welcome, Bilgin, and I will immediately stop sharing so you can share yourself.
Oops, I thought I was sharing.
Oh, yeah. I took it over. Sorry. Go ahead.
Yeah. Hello, everyone. I'll talk about two features that have been added in Dapr 1.18 and how we are using those in Catalyst. The first one is workflow access policies. As you might know, Dapr 1.16, 2 releases ago, added multi-app workflows. And this is actually a very cool feature that lets you distribute workflow executions across multiple applications. So, for example, if you have a business process that needs to execute on multiple microservices for various reasons, you can do that with multi-app workflows. Here, reasons could be, for example, some part of the application might be better implemented in a different language because there is a better ecosystem. For example, you may run part of this process order workflow I'm showing in .NET. The fraud check can be in Python with some machine learning libraries, or the payment part can be in Java, the inventory part in Go, etc. So you can implement the business process in different languages. Another reason might be if you want to distribute part of the application on different kind of hardware, like run it on GPU nodes. It is better to run it there. Or maybe different teams in your organization own part of the workflow and they have their own microservice. Or maybe the data has to reside within certain microservice. So in all of these cases, you can use multi-app workflows. And this actually turns multi-app workflow as almost like another API, another protocol for coordinating different applications in your stack. Talking of different protocols, Dapr lets you connect distributed applications, and there is the service invocation protocol for synchronous request reply style of interactions, and there is the PubSub for asynchronous interactions. And for example, the example application I'm going to use as a demo here, I have 3 applications: a checkout service that's calling the order service, something that's meant to be allowed, and analytics service that's not meant to call the order service. If they were interacting, for example, through service invocation, I can apply access control policies and lock down the order service with a policy like this. Like I can deny all access to order service and only allow checkout service to call the charge endpoint over HTTP. Similarly, I can lock down the PubSub API. I can only allow the checkout service to publish on an orders topic and only the orders app to consume for orders topic. But with multi-app workflows, we have a brand new protocol that needs similar access policies. And that's what's been introduced in Dapr 1.18. It's a workflow access policy. It is a new CRD. It's a new CRD similar to Kubernetes ingress definition. And it lets you, almost like an ingress, lock down the access to workflow API from other applications. It has few key parts. The first one is the scope. This is basically the application where the workflow is running that is being protected. And then the spec, where you define which other applications are allowed to access it and what operations they can perform, like which workflows, activities, and what operations. By default, there is no policy, so access is open. This is also for backward compatibility reason. But the moment you apply a single policy to an app or to all apps in your namespace, it becomes like an allow list. So only what's defined in the policy, only that's allowed. Some other things to keep in mind, for example, self-calls are allowed. A workflow, an app can call the workflows in itself. You cannot block those. And it also has more advanced pattern matching for the workflow and activity names if you need those. So the demo we're going to see will basically protect the orders app from accessing from checkout and analytics service. And the step we're going to do is first lock down all access between the applications using the workflow API, then gradually open it up so that only the checkout service can call the orders app. And we'll show us an example if you want to do something more advanced, how you can do that using YAML files. So let's go here. I'll use an ID rather than CLI. So I have here a very simple project with 3 Python apps. The main one is the orders app, and it has a process order workflow that as a first step, it reserves the inventory. If their order amount is above 500, we'll see that part later. It waits for an external event, and it charges a payment. Now, this workflow app is meant to be accessed by these 2 other apps. Checkout application, this is actually a much simpler version. All it does is it calls the order app and the process workflow. Analytics app is exactly the same. It also tries to call order app, process order workflow, but we will try to lock this down, right? That's the goal. So what I've done is I installed the dependencies, and I'm running this against Catalyst so we can see the visualization. So the scenario we're going to do is we will allow access from checkout to call process order, and we'll deny access from analytics app. So I have the applications running in Catalyst. We can see those here, and no workflows at this point. So if I just trigger the checkout service to, let's see how it goes. Yeah, it started the workflow, I believe. Let's do the same with the analytics service. And if I refresh here, hopefully I'll see those workflows. I see 4 because I have basically calls from checkout, analytics, and both are calling this process order workflow. I can now, we'll start lock this down. So both of these calls succeeded. So what we can do is I can use the Diagrid CLI and quickly create a workflow access policy, right? And just give it a name without any spec, no scoping or anything. Let's do that. So this created the spec, and let's inspect how that looks like. briefly, it's a workflow access policy. The important thing here is the name. We're going to use that while editing. As you see, there is no spec and there is no scope. So this applies to all 3 apps, and it's basically locking down any kind of access. At this point, if I try to trigger a workflow from the checkout app, let's see what happens. Back here, as you can see, the checkout order failed. Let's go and see what happened. So you can see the error message here shown at the top of the checkout service. And it says sub-orchestration task failed, access denied by workflow access policy. And actually, I can see it failed at the point when it was trying to invoke the orders app as a child workflow. I can also see it on the graph if this had a more complicated structure. Now, the error message doesn't leave doesn't leak any details about the policy, the name, the rules, etc. It just tells you exactly what failed, but without leaking any of that. What we want to do in our case is actually we want to open up this policy for the checkout service, but not for the analytics. So what I'm going to do next is going to run Diagrid workflow access policy update. I'm going to scope this policy only to the orders app, not to all the apps. And I'm going to say, basically, allow the checkout service to be a caller. So let's run that. All right. And at this point, if I trigger again, 2 calls, one from checkout and one from analytics, the checkout one should succeed and analytics one should fail. Let's go and see what happened here. Let's just see the root workflows. As you can see, the checkout one this time succeeded, but the analytics one is still failing with access denied. Basically, this shows how you can lock down selectively access to your workflows API from other applications. The CLI here gives you a quick way to create these policies at high level. But if you want, for example, to apply a more advanced policy, you can do by directly applying a YAML file. Here, I'll just apply this YAML file, and let's see what's actually in that YAML file. If I go to order policy, here is an example of a slightly more complex scenario. It's the same policy, I'm just updating the same one, and it protects the order app. And it says checkout service can call process order workflow with the schedule operation. I can also specify some activities it can call, cancel order, initiate refund with pattern matching. So in this case, it would be any activity that starts with this string. Or I can even open it up for the analytics app. If the analytics app needs to call the order service, but maybe it needs to call only something like a generate refund rather than setting orders, right? So you can apply more advanced policies directly with YAML. So going back to the slides, really what we've seen here is using the CLI, you can quickly deny all by default for the whole namespace. That can be a good starting point if you want to lock down everything. And you can gradually open it up if you want for specific apps, or if you want to do something more fine-grained, you can do that by switching to YAML files. Really, that's the suggestion. To wrap up workflow access policies, it's a new CRD 1.18, very easy to understand and use, similar to other network ingress policies. By default, it's backward compatible, so you don't have to do anything, but it's a good idea maybe to start with deny all and lock down your workflow so not every application can trigger them. And the cool thing is you don't have to even restart your applications when you change these policies using the hot reloading capability that also became GA in 1.18. So you can apply those on the fly. In terms of what's next, what you've seen on the example is actually only the schedule operations, and that's on purpose. In this release, only this operation is supported, only basically starting workflows. In the future, we'll support, in the next release, we're going to support the other operations. For example, you can imagine you may have an application that starts a workflow, but you may have an admin application that can be allowed, for example, only to pause, resume, terminate, purge. and a third application that's responsible to raise external events. These are all possible scenarios with these access policies. Another thing that is on the roadmap is the cross namespace calls. Today, multi-app workflows are only allowed within a single Kubernetes namespace, and that's for access control policies. But with workflow access policies, we can open this up and allow calls across namespace. So for more information, the best place to look for this would be the Dapr docs with the workflow access policies. All right. Is there any question for this part?
No questions at the moment, Bilgin. So no, good stuff. But you can continue. Yeah.
All right. The next thing I want to briefly show is human in the loop and how we expose that in Catalyst, and what feature in Dapr 1.18 enabled us. As you know, Dapr Workflows lets you define a deterministic business process in code, whether that's defined in code or generated by agents on the fly, with a prompt and LLM. Both are possible. In both cases, these are durable execution of some kind of logic. And in many cases, you may want to escalate that and have a human, for example, to intervene. Some examples here are exception handling. If an agent basically goes blocks and needs an input from a human, for example, it needs the goal to be clarified. It's not clear what it has to do. Or if an AI application agent produces content that needs to be reviewed by a human before sending it out. If, for example, you want to escalate some high value or sensitive decisions like legal, financial, medical, HR scenarios. Like all of these are examples where certain high cost or high to reverse actions need to be reviewed by human. And that actually has been available in Dapr, right? Using wait for external events and raising an external event. We will use that in the second part of the demo. In the same demo we had earlier, if, for example, the order is above 500, then it goes for a human approval. That's the part we're going to review. Now, what came in 1.18 is actually ability to discover these external event and expose that. Prior to Dapr 1.18, when a workflow was in a running state, in scheduled state, there was no way to know whether it's waiting for an external event and what's that external event. 1.18, what it does is it adds, it's called synthetic timers for every external event. So if you don't define a timer in your external event, there will be one defined, and that timer also carries the name of the external event and makes that visible in the history. That means you can now discover, looking across all your workflows, which ones are actually waiting for an external event. If you find one, you can inspect where exactly it's waiting. You may have, multiple branches and multiple places where it's waiting, and raise those events, something that you've seen earlier. And that's the demo we're going to see. We'll look into finding those workflows, inspecting, and raising an event. So let's do that quickly. Going back to our application, it's the same application, and all we're going to do is this time we're going to send orders just with bigger amounts than 500. So let's trigger the first one. If you go to our workflow list, here I can see all workflow executions across all of them. I can filter by which one is parent, child. I want to see only the parent ones. And the new thing we've added here is ability to see workflows that are waiting on an external event. Actually, I think I need to, the workflow that's waiting on an external event is a child. That's why I'm selecting this option. And here is the step where it's waiting. Now, at the interest of time, I'll quickly raise this. So I set it for 60 seconds. And then we're going to see the details. So what happened is I was able to see where is the where exactly the workflow is waiting for an event and raise that, and this workflow finished quite quickly. Let's do that one more time with the second one, and we'll see more details. So if I send another order for high amount. Here again, I can see there is a new workflow that's waiting for an external event that lets me quickly, remove all the noise. I may have multiple workflows that are running, but only, few of them are waiting for an input. So let's go to this one. It's exactly the same position, but this time I'm not going to raise this event. We'll wait for this to expire. And here you can see the name of the event. In addition, you can see at what point it is going to expire. I set 1 minute expiration time. So in 1 minute, if we don't raise the event, it will expire. If I want to raise the event, the name is here and the input you can feed to the event. At this point, we don't know the exact schema of the input that's expected, so you have to know what you are sending to the event. Let's go back, refresh this part, and you can see this time it turned red after 59 seconds because there was no event raised and it expired. And there is a child workflow. Now I can dig into the child workflow and see that that one is also waiting, this time a different event. It's a manager decision. It's been escalated to the manager. Let's raise that. So the manager is basically approving. And at the top, I can see the hierarchy. So this is the child workflow that was escalated to the manager. The process order is the main workflow, and the checkout order was the triggering application. So if I go back, right, I have basically an overview of an event, an external event that never arrived, it expired, right? A child workflow with another event inside that actually did arrive on time, and the workflow continued. This is important because when you are raising these events, you have to raise it with the exact workflow ID, so it cannot be with the parent ID, so you have to actually go to the child and raise it from there. Most likely you will have an application to see those events and raise, but from Catalyst, you can intervene in scenarios where you have to unblock a workflow. Yeah, so going back here, to sum up, human in the loop, it is a very common scenario, whether that's from workflows or agentic applications, to ask for some kind of intervention judgment call from human. It's durably waiting. Even if you restart the application, even if it crashes, when you bring it back, it's at the same spot. You can continue. And with 1.18, you can actually discover those wait points better and raise those events. In terms of what's potentially coming in future versions, we are looking into how to expose the shape of the data, the schema that's weighted from this external event. So when you are raising those events, the different tools can guide you into that, and how you can use human in the loop or external events in agentic frameworks that are benefiting from Dapr workflows. And Casper will tell you a bit later more about that.
Super cool. Bill, again, great stuff. Really brings together a kind of critical feature to be able to see, the human in the loop events, such that you can actually kind of understand which ones they are and trigger them.
Yep.
Thanks so much, Bilgen. All right. Yeah, let's continue with our next speaker, because we're running a bit out of our schedule. So please stay tuned. And we have Josh again talking about workflow concurrency limits. So welcome back, Josh.
Yeah, good.
Ready for the next one?
I'm unmuted, aren't I? Good. You hear me? Yes. I'm unmuted.
Yes.
Good stuff. Yes, I just wanted to show that workflow did fail. It gets very unhappy when the signatures don't match, and it gets pretty angry. So I just wanted to show it did fail. Good. Right. Yes. Workflow concurrency limits. I'll run through this very quickly. Yes. So yes, you can think of lots of different workflow scenarios whereby you're doing maybe batch processing, or your workflow is indeed maybe doing ordering, some kind of payment system, and you're doing some kind of hype sale, or indeed you're doing some kind of data processing, or you've got a service which has limited resource that you're trying to use. All of these things need some kind of rate limiting or control over how often you can schedule them. So in Dapr 1.18, we've added a new global workflow concurrency limit mechanism. Previously, it was the case that we had options to have rate limiting on a per Dapr basis, which was fine and worked. However, it meant that your rate limiting was based on the number of your replicas, right? So it would be n times x, where x is your replica number. And that, of course, can be horizontally scaled at will, of course. And so, yeah, kind of tricky number to get, and kind of dynamic in a dynamic setting. So is a global concurrency limit, and so that has moved the budgeting, the control of the rate limiting into the scheduler service. So that's one of the Dapr control plane services responsible for scheduling. Act reminders, which is what's backing kind of the pushing the kind of workflow state machine forward. And yeah, so we've added that in scheduler so that so you can do global limits, and that is stable across replica by scaling events effectively. And you can set a max number of activities and workflows invocations at any one time. And then there's also putting named like per activity limits, per workflow limits, which means that you can set a huge global limit, and then you can have limits on the per workflows and per activities. And the way it works is a rate limit event will occur as one of those budgets is exhausted effectively. And so yeah, I think that's all I wanted to show for that one. I'll pass it back.
So with that, Josh, and Claire, the rate limiting just means that it just throttles them back, but keeps them going in the end. Yes. So it just
absolutely,
allows you
so
just
nothing
to
gets
make sure
it just slows down. Yeah. Nothing
it just slows things down,
failed or anything like this. It just slows down. Yeah.
So if you have like a
so you can imagine if you've got yeah, exactly. A connection pool, or you've got a set number of GPUs, and you're going to hard lock an activity to a per GPU or something like that.
Excellent, good stuff.
Right. Let's move on to our last speaker, and that is Casper, talking about what's new in Dapr Agents. Welcome, Casper.
Thank you. And let me quickly share my screen. I'll do the entire screen. Yes. And you'll just let me know whenever you see my screen.
Yeah, we see it.
Perfect. So I'll just go quickly over the updates on Dapr Agents since we participated last time. I want to highlight that Dapr Agents follow its own version and cadence, release cadence. So Dapr Agents is still 1.0. It was 1.0 and released for GA in March. And a lot of stuff has gone in since then. We've added the Anthropic and Mistral chat client, so they are native to work in there. We've added hooks for the workflow loop. I'll demo that in a second. And then we've added hooks for the agent runner. There is an interesting thing coming up with Google Summer of Code student that will use that functionality, but effectively it allows you to write plugins to the runner of the agent, and the other hooks that I'm going to talk about provides you the ability to write plugins to the agent's workflow loop. And then we've added the base executor, which is another type of executor, which allows us to use the Claude agent SDK as the underlying executor while still using all of the constructs within the durable path. Then there's been a ton of resilient fixes, fixing settings on the gRPC channels, renaming some of the bindings between the names of the workflow and the activities and stuff like that. And then other than that, a ton of version bumps, fixing God knows how many vulnerabilities that would otherwise reside there. So that's a continued effort ongoing. So talking a little bit about the hooks that I'm going to demo today, and there is a on the slide deck, there is a link to a webinar I ran last week, which goes into the other side of the hooks. The hooks is effectively to be seen as 4 entry points into the agent's workflow execution. The agent workflow is, and it doesn't matter what agent framework it is, it's rather trivial. You have like a trigger, it'll then converse, and then some will call that think, but I don't think it thinks. It just does the thing that the LLM does, returns, then it decides whether it's done with that, or whether it should call a tool, or whether it should iterate back and run that loop again. That's the loop. And we're providing 4 entry points, or 4 hooks that one can write up against. In this, the first one will be before any LLM call. That is what this webinar is demonstrating, where you could write like a RAG. So you'll go out and retrieve and then augment the context for the LLM to provide updated responses with. It can be a post generation, so post the LLM loop. There could be you want to filter, or you want to pass on further downstream. You want to pass on a specific template or a specific data format. Then it can be before any tool call. We're going to demonstrate that today. And a good example of that could be that you want to approve the execution of a tool call by a human first. And it can be post tool call. Let's say that you have a database and you want to do PII masking of any returns before that then gets returned to the LLM, and thus whatever provider that is could be something that you have there. So I'm going to use the hooks plugins to demonstrate how we've implemented human in the loop for Dapr Agents. So it's going to sort of build a little bit on top of what Bilgin demoed before, but this is just the agentic version of it. And then I'll talk very quickly about how we're going to use these hooks to write extensions with the upcoming plugins, and then what's next. And during my demo, I will actually already, indicate some of the things that will come next. So I'll show you and tell you what are the things that are coming and what are the things that are part of the hooks and the human in the loop. But I am so excited about these things that I can't wait to show it. So bear with me. Mark, let me know if you can still see my screen. I'm showing like a full screen window of my VS Code.
Yeah, we see VS Code and Catalyst. Yes.
Yes, perfect. I learned this the other day preparing for the webinar, because I was so tired of swapping back and forth between my browser and then into VS Code. They now have a built-in editor.
Yeah,
and it's
this
the
is
coolest
nice,
thing ever, and I'm going to use that in all of my demos moving forward.
Cool.
So I have this project. I'm not going to dive into the code base, because we're just going to release this agent publicly shortly, so you can go into it, and then we'll figure out how to release and cycle that link to the GitHub repo. But this effectively shows the human in the loop part and builds on top of what Bilgin showed. So I will first run my agent. And then when it's up and running, we can inspect it a little bit and see what's going on. The agent uses 2 hooks. One is coming, and the other one is already there. The first hook is an ask user hook, and it's part of the upcoming features for streaming that will go there. This will be super effective if we wanna go out and ask the user, hey, we're not really sure about what you want. So the LLM will be able to say like, hey, I'm not really sure about what you want. Can you enrich your question, or which direction do you want me to take further downstream? And the second one will be the allowance, or the triggering, the approval by the human. So we're up and running, and we have the release agent. The agent, let me just quickly refresh. Oh no, there we go. So the release agent is a rather simple agent, just has a system prompt. It does have the publish announcement tool. This can actually publish into Slack. Uses the OpenAI chat client with a small model, and then it has this chainlet UI. So we're going to trigger it and ask it to create like an announcement for the 1.18. As you can see, the logs are running. I'm not going to show the full set of logs, but the agent underneath is out now, fetching some details about what is actually in 1.18, because I can assure you that the 4.0 mini has no clue about Dapr's 1.18 release. So now we have the asking thing. This is the first hook. It's not there yet. It's a coming hook, but it's a clarification. So like, what exactly do you want to highlight in this? And I think the workflow verifiable execution is pretty darn cool. And I think the history signing is pretty darn cool. So I would like it to focus on that. So now we shut that off, and now we're getting ready to build and execute the tool. And we hit the approval gate. This is just the visualization of the approval gate within Chainlet. This announcement for me and the purpose of this demo looks very good. So I'm going to approve that. And then it's publishing, and it'll return. And now you'll see the next part that is coming up, the streaming replies coming back instead of coming in big blocks of replies. This is an upcoming thing. Incredibly excited about getting to that point. But let's jump back into Catalyst. And now we can go down into the execution. We can see the execution was to draft and publish the 1.18 release announcement. Let's jump into the overview of that. And I'll zoom. So just like Bilkin showed, you'll have the publish of the event that, hey, I would like you to highlight, or I would like you, dear user, to pick what you want to highlight. That then creates a timer, and we wait then for the user to respond. And this is the response we got from the user. So now we can continue our execution down all the way until we got like, oh, I need to request an approval. We put the wait, and we waited a little bit longer because I was slow at approving it. I really needed to think a lot about it. And then we have the approval that continues on, and then it continues its execution. And as you can see at the end of it, we have the final full output of it, including the reply from the assistant. Even though it was streamed live, the whole handling of the durability is still persisted correctly and fully durable, so we can recover from any failure, even if it dies midstream. So that was my demo. I'll jump back into the slides and go there. So what is really, really exciting for me about these hooks is that they allow us to create entry points, or they have allowed us to create entry points where we can modify the behavior of the execution. So what we just saw and what we're going through is the approval of continued execution by some entity. What we didn't see was what entity was approving. That was me, but nobody actually checked that. And the way we're going to figure out who that was is we're going to write another plugin that'll allow the agent to understand OAuth and to verify whether I'm allowed to actually invoke that approval request or not. And then we'll also implement through the same hook system and on behalf of token flow, which effectively just means the agent will be able to exchange the OAuth flow into an on behalf of token, so that the agent can then work on behalf of that user. If we imagine using a GitHub MCP server instead of being agent 1234, it might be better and more relevant to be agent 1234 working on behalf of Casper from Diagrid. So those are two upcoming things that we're working on right now to get out, and they will be usable as extensions, as plugins that you can just tap into the code base and start to say, like, I want to do it before the LM call, I want to do it after, I want to do it before a tool call, or after, and so on. And then, as I showed during the demo, there will be the streaming. The PR is already up there, so if community members feel like it, please go in and review it, pull it down, test it out, share your feedback. Would love to have it. It's both supporting the single agent instance, but also the multi-agent instance. Any feedback would be super much appreciated. I am very excited about these two upcoming things. I think I've said that multiple times. And I'll then, with that, give it back to you, Mark.
Cool. Excellent, Caspar. Great demos. Good to see this in action. Thank you
Yeah,
so
it's
much.
good to see so much happening inside Dapr Agents. It's an amazing framework for building agentic applications.
Excellent. Yeah. We definitely want to see more demos of that, and also people using the release agents, right? I mean, it would be great to see that more actually in use, and also being out there in the public. Great
Maybe
stuff.
in the next community call next month, we can do something, dive in on that.
Oh yeah, sure.
Some of that.
Why
I think
not?
that'll be a good time to do some of this.
All right. We will do this very quick because we are already 15 minutes over time. So I already rolled my my purple dice here, Nita, for the winner for this Lego Back to the Future kit. It is Carlos Osoria. So Carlos, thanks for staying online here and watching all of these sessions. I will contact you via email about your address, so I know where to send this to. Thanks a lot. All right. So, well, I hope you really enjoyed this. We've shown a lot of stuff, a lot of demos. Sorry it took a bit longer, but it is good that we've shown all of these features in depth, right? Because it's actually good to see some actually working demos and not just that we're talking about it. So I think it's good that we took a bit more time. There's definitely enough material to learn more, right? So you can learn about AI and Dapr on diagrid.io/university. So check that out. There's a new Dapr Agents course that Casper actually wrote about it, but also shows how to use this Dapr Agents hooks system. So definitely try that out. And for the people who are more .NET focused, there's a .NET Dapr Workflow with Aspire course as well, which is very new. And of course, try out Catalyst, right? Because Dapr 1.18 is already available on Catalyst. So yeah, definitely try it out. You can see all the very fancy workflow visualizations, all of the workflow management things in there. So give that a try. For the ones developing Dapr workflows locally, there is a dashboard. We did not demo that today, but yeah, we have like a very useful dashboard that you can use to inspect your workflow state, the local workflow state. And finally, yeah, if you have any questions now, please go to the Dapr Discord. So that's diagrid.ws/Dapr-Discord, and we can continue the conversation there. Thank you very much, everyone.
All right. Great session. Great to see all this work, and see you next time.
Yes. Bye-bye.
Bye.
Bye.